Hey everyone, I want to welcome you to the next Math for the Impatient. Here I am with Kladko, our CTO, and today's topic is Scale Full Sync Node. So let's talk a little bit about Scale Full Sync Node. It was just released. Maybe Stan, if you could tell us a little bit about it and how it's helping our customers run their dApps.
Yeah, it's a great question, Marcus. First of all, we are celebrating because we actually released this thing. You know, sometimes we talk about different things during this podcasts, and usually it takes us time to engineer them. So we've been talking about full sync node already for quite a while. The original idea was that many customers told us that it's great that we're providing them these 16 nodes, we're providing them the blockchain, but they also want to have like their own copy, pretty much for two reasons. The initial reason was they want to have like the entire backup of the entire blockchain just for themselves, just as another way to do it securely. So it started with a backup, but then there was another thing, like people started to run computationally intense things around such things like browsers, block explorers, and they realized that it's super great to offload some of the computation to the sync node. So essentially you have the configuration where you will have 16 nodes that doing the actual blockchain consensus, and the sync node is actually constantly catching up with these 16 nodes, but then browsers, block explorers, dApps can connect to this node and offload computational processing from the core blockchain. And it's what's kind of an enlightenment moment for us, because it's like, you know, when you have a startup, you release something, and sometimes people give you ideas that you haven't thought of much. And that was actually an example with the full sync node. This is actually a feature which was totally suggested to us by customers. So they said they need this archive, and then they said they need something locally to connect the browsers, to connect block explorers. So we really developed in a very like lean startup way, where we actually are doing what customers are asking us. And so now we released it, it's working. Now you can take a machine at home, and if you have a scale chain, you can connect this machine. You can download in a very simple way, download software. We made it really, really easy to do. And then you run the software, and then guess what? You have your own copy of a scale node. And then instead of putting computational load on the core chain, whatever you want to do, you can actually access this node. So far, the response from our customers has been great. Several of them already running this node. And this is one of the features that was one of the most wanted features, because now these guys, they actually can have their own a live archive of the entire chain.
Cool, awesome. Okay, so it's out, it's running. We're super excited about that. We've got some people using it. Next obvious question is, what's the future of full sync node? Are there some, excuse me, new features that you guys are working on that you can tell us about?
Yeah, that's a great question, Marcus. And again, it's interesting because now we released it, and almost immediately, once we released it, we started getting new feature requests for it. And so now we realize that this sync node can be not a sync node, but also do something else. And I'm going to talk about this now. We even think about maybe changing the name, because sync node just kind of supposes that you only sync data. We may actually change it to something like a helper node. Because what we realized is that we're running this core blockchain, and just to save money, you know, there's only a fixed amount of computational power on this blockchain. So whatever we can do to offload the computational power helps the blockchain. And now the sync node will offload things like transaction view, transaction display, browser connecting to the node, block explorer connecting to it. It's basically reading information, retrieving information from the blockchain. This can be done through the full sync node. But now the customers are saying, why can't I actually send transactions to it? And then once they told us this, we realized that the full sync node can not only read data and sync data, but it can also serve as a kind of a front end, so people can submit transactions to it. So we then offload the part actually before consensus happens, because blockchain is that transactions are submitted, kind of massaged into blocks, then there's a consensus, and then the EVM processing. So we realized that the transaction submission can also be offloaded to this node. So then if your blockchain is super busy and you really, really want to make it run faster in terms of the TPS, transactions per second, you pretty much want to offload everything you can except the core consensus. And this actually allows us to offload the front part that happens before consensus, so all the transaction processing. So we started this new feature request to add transaction processing to the full sync node, so it can accept transactions and broadcast transactions to the core blockchain, to all nodes in the core. And so we started the feature request, and then now customers are coming saying, you have to do it now, basically. It turns out this feature is very asked for by the customers. And so basically, now one of our guys is actually working hard to implement this feature. So the full sync node is able to accept and process transactions and do the entire like front thing that happens before you do consensus. And it's very exciting, because if we do this, almost very probably that the performance is gonna, the RTPS is gonna go higher, because you'll offload computational power. So now there's lots of interest at Scale actually to implement this feature and then measure TPS to see how much we can actually drive up TPS by offloading some of the processing to this sync node, where like the sync node is not a good name anymore. So we're thinking, as I told you, maybe to change it to something else, something like a helper node. And then you have the architecture where essentially you have the core chain, where you have 16 nodes doing the consensus, but then by adding helper nodes, you can offload the front processing, the front end processing, and actually then the core chain is protected, including protection against denial of service attacks. Because if helper nodes accept transactions instead of core nodes cannot be DOSed, denial of service attacked, right? You will have to attack helper nodes, but they can be much more helper nodes potentially, and the app can actually keep on adding them if someone tries to attack. So it's like really interesting, because we started with something tiny, which was like proposed by customers essentially, and we're kind of growing this into like a different architecture now, where in addition to these core nodes that run the core chain, we have these front end nodes, the helper nodes, and lots of processing, and those protections are gonna actually go into these helper nodes. Now, the last thing, which is really interesting, just a couple of days ago, we got a request. One of our customers said, you know, we want to do like a Web3 website, but you guys don't support Node.js, because their web environment is Node.js, is very popular. Scale currently doesn't support Node.js as a web server, right? We do run Nginx, but we don't run Node.js. And then like it was like really interesting idea. We realized that because the helper node or the sync node is in hands of the customer can do anything. So if the customer doesn't like Nginx that we provide by default, and the customer wants to do a website in Node.js, the customer can just add Node.js, installed Node.js to the helper node, and then suddenly use Node.js. So then the system becomes really customizable, because we only control the core, and the customer control all of these front-end nodes, and whatever they want, instead of asking us, they can actually do it by just installing whatever software they want. So it turned out to be a very happy architecture, where there is the core that we control, there is this set of front-end nodes that we won't control, and it actually allows lots of innovation, because you can pretty much install these front-end nodes in whatever way you want. You can modify them, tweak them. It all goes into the customer hands. We don't even know.
Very cool. So you're doing all sorts of new load balancing, which I think is kind of critical and important to Scale. You got new security features, and then you're also supporting a lot of really interesting things around people who want to support the web, which is, going to be critical. The web isn't going away, even if Web 3 is taking over. There's still a lot of Web 2 things that people are going to want to take advantage of. So, the obvious next and logical question is, when will the next version be released?
That's a great question, Marcus. And we kind of thinking about releases, and we're trying to keep the system slowly evolving, because blockchain is supposed to be very secure and stable, so we cannot change things fast. So we're only adding features which are really, really important. But this feature of being able to broadcast transactions does seem to be very important, because people are asking it. That's number one. And number two, it provides a security solution to a pretty significant problem that pretty much any blockchain faces, denial of service. So someone can attack us. Hopefully, happily, luckily, we didn't have any attacks yet, but we may. And by the time we start getting denial of service attacks, it's important that we have architecture that protects. And this is just really, really good architecture, because if a helper node is able to accept transactions, the core nodes can be totally inaccessible by anonymous users. They will be only accessible by the helper nodes. So if a denial of service attack happens, it will go not into the core nodes, but into the helper nodes. So the core nodes will keep on mining blocks, and the front-end nodes, the helper nodes, if the attack goes into them, well, ultimately the DApp developer can just run many nodes, or just run more powerful nodes. There is much easier to protect against denial of service attacks, because you can dynamically scale computational power, while for the core nodes, the computational power is set, and we cannot dynamically increase the computational power in case of a denial of service attack. So to make a long story short, this is like super important for us, not only from the feature perspective, but also from the security perspective, which is really important for us at Scale. And because of that, we really decided to make this high priority, this solution. And the engineering work is being done. Then there will be QA. So it is going to go into the next release. Something that we call 2.1. We decided to do like a minor changes, not to scare people too much. So instead of calling it Scale 3, we're going to call it 2.1. So it's going to go into 2.1. And the idea is that 2.1 is going to include really important features and be released, I would say, from 1 to 2 months from now. So several more weeks of engineering. Then we're starting the QA process. The QA process is also going to be very significant and very thorough, because it's blockchain and it's a financial application. And when the QA process is complete, then we're going to release it. And I really hope that we should release it this summer. And it's really exciting, and it just changes totally the potential architecture in which Scale operates, and allowing DApp developers to add additional computational power to the Scale network without affecting the core blockchain.
Right. Interesting. Very cool. Okay. Well, that was full sync node. Thanks, Stan, for going through all of that. Look below. Make sure that you like this. Make sure that you spread the word. Please join our Twitter and our Telegram. We have an announcement channel where we talk about all of our announcements on a pretty regular basis. Please join there. Everything's below. Thanks again, and until next time.
Bye, Marcus.
Bye.